Thank you so much. And right now, I would like to invite you to the workshop with Laurence, Kirk on auditing zero-knowledge contracts.
Stage is yours. Thank you. Just wait for people to clear the room, and then I'll just wait for people to clear the room, then we'll make a start. All right. Thank you for coming to my talk, everyone. It's good to be here. Thank you for inviting me to this event. Now, in common with the previous talk, I'm actually going to start off by talking about T-shirts. In fact, I'm going to explain my T-shirt. So this is my emergency ZK Maths T-shirt. In case of emergency, I can look down and I've got some maths ready for me. If you're interested, if you'd like one, then come talk to me afterwards. You can have one. All right. So I'm talking about auditing zero-knowledge contracts. So these slides are available. If you go to the website there, you can get them as well. If you want to join our Discord, please do. There's details there. I'll get out the way so you can have a look at the QR code for that. Or you can ask me later also. All right, so what I'm going to talk about, so just a little introduction. I think probably we can skip most of that because you probably all know features of ZK systems already. You probably also know most of the major protocols. Then we're going to look at some of the vulnerabilities. And the focus of this talk really is with, where I'm aiming it for is for people who are beginners in this space, and perhaps if you've got some experience auditing or looking at security in other systems and you're thinking, well, how does this apply to ZK systems? Then that's what I'm going to try to explain. We can then look at some tools, look in details at some specifics about ZK, and then have a further discussion. So motivation for this, well, this is taken from L2B to show to give you an idea of the TVL that some of the layer 2s have. Now, before anybody gets upset, I know ZK does other things. It's not just there for ZK rollups and layer 2s, but this is just an indication of the amount, perhaps the targets you might like to think of it as, that is available if people want to attack contracts that are written on ZK protocols. So there's a lot of funds available there to be attacked. So how is ZK used? Well, we've got some aspects. You could say it's all about proving computation, and particularly if we're thinking about ZK rollups, we're proving computation of the transactions, the execution of the transactions was correct. Can be about privacy as well, so we shouldn't neglect that, although a lot of these, a lot of L2s are public chains, so they don't really care about the privacy aspect. Some of the features, well, of course, it's an interaction between a prover and a verifier. When you think about this, though, it's interesting to think of, well, who are these people? Because a lot of these systems, the prover and the verifier, they kind of end up being the same person, because we've got the same person who wrote the prover, we've got the same person who wrote the verification contract. So if you're looking at the motivations, it's slightly different to the classic way that we think about ZK. But then we have the essential properties, and I'm sure you know these ideas, but these are some things that we need to think about. When we're thinking about how could we attack ZK, then we need to be thinking about some of these that could be broken. Then, of course, in addition to all the other things that could potentially go wrong. All right, so protocols, I'm sure, yeah, you know a lot of these. I won't go into those really, but we have, particularly on the L2 side, we've got a lot of ZK EVM protocols. It's based on, or similar to the EVM. We also got some custom ones where the execution environment is custom, such as using the Cairo VM. And yeah, I'm sure you know all of that. Also, we have things that are not layer 2, so we have layer 1s, for example, Mina, or things that are not necessarily anything to do with blockchain. They just can be used to do provable computation, such as RISC-0. And a typical process that we go through, or developers go through, is to start off with some higher level DSL, and then this gets transformed into a circuit, and then that goes on to be used to create a proof. And so some of the DSLs we'll be thinking about, Cairo, Omena, we've got TypeScript 01JS, is slightly different, but we can kind of think of it the same. We've got Noir for Aztec, and then Rust for RISC-0. So if we're thinking about doing code inspection of contracts, then we would probably be looking at some of these languages. And I'm really focusing, I guess, on these higher level DSLs, although we'll talk about some of the lower level things like Circom as well. So what difference does it make, the fact that we are writing code for a ZK system? Well, the actual implementation does bring out some features. And even though we've seen progress, and I think, for example, with DSLs like Noir, they really did try to develop that so that they could take out they can make it so the developer didn't need to know so much about ZK. It would feel more like just writing any other language. But even so, it does tend to intrude. The details of ZK do tend to intrude, particularly with things like data types, with the fact that we're building on finite fields, and so that can have an effect on the data types that are available within our language. Also, the fact that we have modular arithmetic being involved as well makes a difference. And we need to, when we're auditing and thinking of potential vulnerabilities, we do need to be aware of this. This is something that could be exploited. It's good to think about from a kind of a high level or in a more abstract way, well, if someone attacks the contract, what could they actually do? And usually people attack contracts or programs because they want to steal some funds. So we could have that. So you've got the example, if you're attacking Zcash, for example, maybe you could mint some extra Zcash. And there was, of course, a famous vulnerability early on with Zcash where that could have happened, but they think it didn't. But that's the type of thing you need to be thinking about. What potentially could go wrong? What could an attacker get out of this? So potentially they could use it to perhaps steal funds, and that kind of ties back into the targets I showed you earlier. Also, there's the possibility of breaking privacy. If privacy is involved in our systems, then that potentially could be leaked as well. Another point that I would like to make is that I think there is a subtle difference when we think about the kind of systems that we have. And perhaps we would be inclined to put more trust in some of the ZK systems because they're involving a proof. We think, therefore, it's more rigorous, and therefore maybe we will trust them more. Maybe we'll take more risks in what we are doing. Maybe we will invest more in them. So there's that is something to be taken into account as well. Also, you need to remember some aspects of ZK in that sometimes we're not sort of necessarily looking at trying to compute a particular value. We're more trying to show that a particular value that has been computed perhaps elsewhere is correct, and we're creating a proof of that. So there are quite a few aspects of the implementation and the philosophy behind ZK that differ from the types of things that we will be looking at in ordinary, maybe Web3 contracts, when we're looking at auditing and thinking about vulnerabilities. Okay, I'll just quickly take you through this, although I expect you probably do know this. I do like this diagram. This is taken from a very good paper, so please do go have a read of this paper. It gives you a system of knowledge of vulnerabilities in Snark. So yeah, really useful thing to know. But it has a nice diagram to show you the general process. So we've got the real world and Snark world, which is where I'd like to live. We start off with a setup, which gives us a summary of the setup, proving keys, verification keys. Once we've got that, we can have a prover creating proofs. It's going to depend on a witness, maybe some public inputs as well. That can be sent to a verifier. The pi here is our proof. That can then interact with the real world and can say, yes, this this state transition was done correctly on layer 2, something like that. So it can, that information can travel further. Now from that report, from that paper, it looked at some of the, it gave a breakdown of where we tend to find vulnerabilities. Now this, I think this is based mainly on Circum-based projects, so it's not necessarily looking at sort of the layer 2s, but it's fairly early days. So, but it does give you a good idea of where things are seen to be going wrong. And this is taken from audit reports. So do also bear in mind that this is just the things that we have discovered. It doesn't mean that, you know, it's not a description of everything that's out there. But you can see that most of the problems we get are in the circuits themselves. So this is the actual, the way that, you know, the circuit has been written, or it could be if there's a DSL, how that has then been written or transformed into a circuit. And the types of problems we tend to get more of are the soundness. So let me go back to my, I had a definition, I think. So the idea that we could have a dishonest prover. So a dishonest prover could create an incorrect proof and yet get that past an honest verifier. So that's the main area that we see problems being found at the moment. But of course, you know, these systems aren't in isolation. They interact with other, you know, with front end, back end, etc. So there could be problems there also. There's further links there for you for further examples. Just to mention a couple of these, I'm not, yeah, I don't have too many examples, but I'll just mention a couple. One very common vulnerability we get is the idea of under-constrained code. And certainly if you're developing for ZK, you have to be, you have to put much more effort into making sure that exactly everything that you need to prove is actually being tested in your code. It's extremely important, and it's very easy to miss something. So maybe you introduce some variable, but you don't check that that variable isn't 0 or isn't in a certain range. And so a lot of vulnerabilities fall into that category. Similar to that, very similar, it's quite difficult to work out the difference perhaps, but the idea of the non-deterministic circuits as well, where there could be, I mean, possibly you could have some randomness or some values being input to make the circuit behave in a way that is unexpected. Other things we need to be aware of, I'm sorry this has gone on to an extra slide, but because we're doing modular arithmetic, we have the potential for underflow and overflow, so you need to be aware of that. I suppose we also get this, you need to be aware of it also in, you know, in Solidity, something like that, but certainly in ZK you should be aware. This is just an example of if you're assuming that we're getting a result here of, well, A is 11, and you think, well, what values will make that up, and you're going to be testing for them. Well, in fact, there are two possibilities shown here that maybe you wouldn't have thought of because of the way the mod arithmetic works. So it's something else you may want, and in fact you may want to check and then constrain that maybe Z would be equal to 0 in this case, because perhaps that's the one that you would be interested in. Other things, just an example I thought up, if you imagine we're writing some code and it's going to represent some kind of accumulator, something very simple. If you did this in a traditional program, it would be very simple. But then when you need, if you're going to turn this into a circuit and you're going to make this provable, then you need to have all sorts of extra checks in there. So you could write this out. Now, really, when I wrote this, I was thinking of the way that we get this in Starks and the way that they work, and we have all of the initial, the boundary constraints, etc. But you could write this out and simplify it by saying how to go from one row to the next. And you could constrain that, but then also you would need to think of things like, you know, what are the boundary constraints? Where do we start? Also, you know, the steps here, the totals. What ranges should they be in as well? Are we checking for all of those? So there's so many more things that we need to be proving when we are writing for ZK. Something else that is quite new, I think, and I find this this is quite difficult to sort of quantify and know what we can do about this one, but we've got the possibility of doing off-chain computation. So I'm particularly thinking here of, say, Mina, which is, but also we've got Aztec and Alio that do this. But the idea there is that you have some computation being done off-chain, and then you can post a proof of the correctness of that on-chain along with the results of that. And that's how Mina works, for example, how their contracts work. But then this is really quite a different idea and a different paradigm to things that we've seen before. And it makes it quite difficult when you're thinking about attacks to add this extra paradigm in. Another aspect that is difficult with this then also is to synchronize updates. If you're doing things off-chain, multiple people could be making updates, and getting those synchronized is difficult from a development point of view, but then that also means that auditing it is going to be difficult as well. I'm thinking particularly of Mina here, where one way they have a particular solution to this, but then other people have also used things like a sequencer to get around that, but then that is centralized, so we don't want things to be centralized. And then also another problem we face with looking at potential exploits is the fact that we could end up with a mix of code where some of it is provable and some of it doesn't need to be provable. And again, in Mina, you get this where you can have some code that maybe will calculate some results or do something, and then you have a section that is going to be provable. And so you then have to think about the interaction of those, and that the fact that we've got that, and you need to make sure you've got the mix right. You need to make sure that everything that needs to be provable is in the provable code, and you haven't left anything out. Okay. Are there any tools to help us? Well, there are some, and these, again, from the paper, I think, or maybe from an article. But these were really tools that I think apply to things like CIRCOM, so they're to sort of earlier things, not necessarily to some of the higher level languages, but there are some that help us. We've got formal verification tools, static analysis, symbolic execution tools as well. I don't know if the people here are auditing, but and what they feel about using tools generally. I tend to think of them as, well, they're a useful thing to do as well, but in my experience, most of the vulnerabilities I found via code inspection rather than from a tool. But again, it's early days, and so they're perhaps not very mature. We recently did a series. If you want to, you can have a look on our website. We have a series teaching people to audit Cairo. So if you're interested, do go and go through that course. But on there, we specify some of the tools that are available for Cairo as well. So we are getting some of these coming through, some static analysis tools and some more formal tools. I'm not sure about, Horace was from Nethermind. I'm not sure the status of that. I think that may be for Cairo 0. I don't know if that's been developed. Do people know how to pronounce the third one down? Apparently it's pronounced Tort or Toss, I think, not as you might think. But anyway, so we are getting tools coming through, which is good. It's a good adjunct to doing the code inspection. But what I would say is, perhaps picking up that point, when you're auditing, I tend to rely on code inspection, but also one of the most important things you can do is to take an attacker's mindset and to be really determined to break the contract you're looking at and try to find it, and imagine you want to steal the funds or whatever. And that is often one of the most useful things, and perhaps more useful than running a tool against the contract. Now, one problem with ZK systems as well is that we may have things that we can find as auditors with limited ZK knowledge. So you may be able to find logical bugs in the code. You may be able to pick up on some of the items I've mentioned already about why ZK programs are a little bit different. But there may also be things that are just going to be found by cryptographers and people who understand really the depths of the protocol themselves. So that adds an extra complexity to the process. Of course, you can, when you are auditing, you can regard things maybe as a black box. So you could say, well, this part, perhaps the compiler that takes our DSL and then turns that into a circuit, perhaps we're going to regard that as a black box. Maybe we're going to assume that that works correctly, but we can't really say any more about this in the audit. We just have to assume that that's working correctly. So you may have to make those kind of decisions. But a lot of things you can see also at the DSL level, such as under constrained code. That is possible. Yeah, this is just really things I've mentioned already, I think, there. These are some examples. I don't think I'll go through them, actually, but if you want to have a look. This was interesting. It was an audit by Trail of Bits, one of the big companies. They were looking at scroll and looking at the way that the EVM was being implemented. And in addition, if you work through some of these points, you will see that in addition to the very sort of ZK aspects, there are things that you could have picked up on without having to have an in-depth knowledge of how the circuits work, maybe. So there are things that you can find, even if you're not a cryptographer. But things such as, this final point here, this is talking about soundness. This is really the heart of what the issues that we are concerned with. Yeah, some more examples there. One, this point here, the Fiat-Shamir transform, I don't know if people are aware, but there was, well, maybe it was a couple of years ago, but a paper came out showing that a lot of the implementations of Fiat-Shamir had been done insecurely. It is, obviously it's used, everywhere because people need to make their proofs non-interactive, but there was a lot of problems with that, and there's a paper about that where they went through many of these systems and found out that it wasn't actually being done securely. So again, it's you really need to be aware of every piece of the process, I guess. We've been auditing Cairo contracts, and again, if you're interested in more details of this, you can have a look at our course. Some of the things that we have found are fairly typical to, or very similar to what you would find auditing Solidity. So I don't know if that's a good thing or a bad thing, but it's something you can certainly be looking for. So things like lack of access control. This is a very fundamental thing that you need to get right with contracts. When people are interacting with your contracts, you need to be sure that the access control is correct. And this is not particular to ZK. This just applies generally. So these are common things. Reentrancy we can get in Cairo contracts as well. And things like, if you know Solidity, you know the problems of using tx.origin. There's an equivalent to that in Cairo that you need to be careful about that you don't use. And then on the ZK side, but the more ZK-focused vulnerabilities, we have things like incorrect maths, where maybe you would get an underflow or an overflow. And this is an example. In this code, there's we need to check, or we should have done a check, that the amount is less than the balance, but the way this is written, it doesn't get checked properly. And therefore this could get through. So yeah, you have to be careful. Reentrancy, there are many types of reentrancy, and these also appear to or can be applicable to Cairo. It's quite sad, I think, that we've known about reentrancy for many, many years, and yet we still see many examples of it as a vulnerability. And we know how to fix it as well, but there you go. Other points, so I've spoken about privacy and the fact that people may have made some assumptions. They may think that data is private. Maybe if they see that something is involving zero-knowledge proofs, perhaps they think there's private data being involved. But often there isn't. With StarkNet, for example, everything there is public. So you do need to also be aware of that aspect as well when you're writing your code. And then in what Aztec are doing now is they're going to have they've got a hybrid state model where they've got a potential mix of public and private state. And so, which is wonderful. I think that's a great thing that we can have. But obviously, if we're going to use that, then we need to be very careful that we don't have leakage between the two things there. So that's it. If you want to know more, yeah, please have a look at our website. We also run audit courses. We've just started doing some audits on MENA. So we've got a couple in progress at the moment. I can't share those with you yet because they're not completed, but if you're interested, I can send them to you later. So yeah, that's details about us, our social media as well, if you want to know more. Oh, there you go. That's everything. Thank you very much for your attention. Thank you.
Do we have some questions from the audience? Okay, Victor.
I have a question regarding maybe risk zero or like some of the ZK solutions with like when you write in a general purpose language like Rust. I'm not sure how to phrase this question. Like, what are the things you'd be looking for, some pitfalls you've seen, or is it just enough to write good and secure Rust code, or do you need to think about more things when developing for this target?
Yeah, thank you. Nice question. Yeah, I think you can perhaps think of it in layers. So you need to get the Rust correct anyway, because if that goes wrong, that's a potential vulnerability. But then we do have other aspects because of ZK. So, for example, things like the underflow and overflow that could be possible. We are assuming, as I said, that the transformation from Rust to a circuit or whatever is being evolved, that is being done correctly. And maybe we have, if in an audit, you would have to perhaps mention that is an assumption you're making. And I say that because we are still quite early in this process, and it could well be that there are problems there. Whereas the Rust compiler is fairly mature, and hopefully a lot of the bugs have been taken out of that. But yeah, for the way that that's being transformed, it's probably still worth mentioning. But yeah, you need to be aware of having the code being constrained enough within your application as well, looking out for things like problems with mod arithmetic that could come up. So it's really layers. You've got your traditional Web 2 problems, you've got Web 3 problems, you've got ZK problems. So quite a lot. Thank you.
Okay.
So, there's another question at the back.
Sorry.
Hello, I'm curious if you see any major trends within ZK, like ZK ML or something like this. And maybe second question would be if during the audits you also need to go down to the bytecode level.
So do you mean generally trends in ZK? Yeah, I mean, yeah, ZKML I think is a particularly interesting area. And again, actually, if you go to the links for these slides, I've got a presentation about ZKML. You can have a look at that. So I think, yeah, that's an area that's expanding very rapidly. Going down to the bytecode level. I think if you are, well, if I go back to something like Solidity, I would, because I may be thinking about an optimization. So maybe I would do it in that case. In ZK, at the moment, I don't know if I have enough knowledge to understand something like Sierra in Cairo, going to that representation and then down to Chasm. I don't know if I understand well enough the process of going down there to make sense. I would perhaps ask then, pass that on to somebody else, a cryptographer or somebody who's involved in that to do that. Because again, it's early days. I'm repeating that phrase, but yeah, it is.
Okay. Thank you.
Thank you.
Okay, so if we don't have more questions, thank you very much for coming and for your presentation. And now I would like to invite you for another 30-minute networking break. And then we can meet here again for 2 lightning talks. Thank you, guys.